What's up guys, welcome back to the Crypto Coffee channel. In this video, I thought it would be fun to learn something new and something you might not know already. And a lot of you might know this, but we're going to talk about what is an automated market maker and what does that term even mean and how do they calculate it and how does it work on the back end. So this might be kind of a technical video for some people. Some of you might not care, but a lot of you probably should know how this works considering that we're trading on Uniswap all the time. So this is related to just the backside, the underside of how things like Uniswap work behind the scenes. Now, when we say automated market maker, for those that don't know, that's also abbreviated by AMM, and it's also what's referred to as a constant product market. So these are things like Uniswap, 1inch.exchange, and really anything that doesn't have a central third party owning all your coins, like the Binances of the world and the Coinbases and stuff. So it's important to learn about AMMs because they are the future and they're the way that we should go if we value financial freedom and financial sovereignty and taking control of our own finances, not handing all of our power away to third-party middlemen who are corrupt and don't have our best interests in mind. So how do these things work? They're really pretty revolutionary and they've been out for a while. You know, Uniswap's been out for I think 2 years now. And on the back end, what's really going on here? So if you ever wondered how the prices are calculated from the various liquidity pools on automated market makers, stick around because we're going to walk through some examples and formulas and even do some algebra. So it's going to be fun. So the formula is pretty simple, right? Let's say I have a regular pair on an automated market maker. It's, you know, for example, the Hex USDC pair or the Hex ETH pair, or any other pair that I want to trade in, you know, the Hex Bitcoin pair, for example, if there is one. The formula before anything ever happens is that the reserves on coin A times the reserves on coin B are equal to a constant that's called K. This is the constant product in the constant product market. And after I buy some of, let's say, coin A, I'm actually taking out of the reserves of coin A and putting in some reserves to coin B. So if I'm buying Hex with Ethereum, I'm actually taking out coin A, represented by the delta A. That Hex is coming to me, and I'm actually putting in some ETH. I'm paying some ETH to get some Hex back, and that's represented by delta B. And let's ignore the gamma for now. That's that Y shape. So in order for the constant product market to work, K still has to equal K, both before and after. But if I take out a certain amount of Hex, that just means that in order for the whole equation to balance out and continue to equal K, that means I have to put in a certain number of Ethereum. And that's how Ethereum and Hex are priced. So that's how the automated market maker would determine how much Ethereum I'd have to give in order to take out the amount of Hex that I'm requesting. So let's go over an example to make this much more clear. Again, K never changes. It is the constant product of the constant product market. Now, for example, I took a screenshot from Dex.Vision, which you can see the Hex Ethereum pair right here. And we've got over here 6,876,270 Hex in liquidity on the Hex side. We've got 1,034 ETH on the ETH side. So these numbers just multiplied together, forget the units, just multiply these two numbers together and you get the constant K. So therefore, 6,876,000 times 1,034 equals 7,110,000,000, you know, the rest. So this is the constant. This 7 trillion number is the constant product. Now keep that in mind while we continue on. And just for example, if you ever want to go to Dex.Vision and calculate this for yourself, you can always find the liquidity and basically the quantity of each coin on each side of the liquidity pair up in the top corner of the graph. Okay, so this is just a screenshot from Dex.Vision. Now, I have a blurry picture up here because we want to remember the numbers, and unfortunately I didn't zoom in enough, but this is the before case, right? Remember, before we do anything at all, we see that there's 6,876,000 Hex and there's 1,034 ETH, right? Now let's say I want to buy 10,000 Hex from the AMM market. Well, remember, K is 7,110,000,000, and we're going to keep that number at the top of our head for the calculation, but now I want to take out 10,000 Hex out of the Hex pool. So in return, I must add Ethereum to the Ethereum pool to make up for the Hex that I'm taking out. Because obviously it's a trade. I have to trade ETH for Hex. So remember that after the transaction, you know, K is now equal to the reserves of A minus delta A times the reserves of B plus delta B. And this basically means the quantity of Hex minus the 10,000 Hex times the quantity of ETH plus the ETH that I'm paying. And that still has to remain constant, meaning equal to that K 7 trillion number. So we're just going to do a little bit of algebra and we find out that, if I want to take out, delta A, if I want to take out 10,000 hex, I have to do 6,876,270 minus 10,000, because there will now be 10,000 less hex in the pool, times a new number of ETH, so 1,034 ETH, plus some delta B, which the delta B is, again, the amount of ETH I'd have to hypothetically pay. And that has to equal 7,110,000,000. So you can do basic algebra, right? I mean, we've done this before. It might have been a while for you, but let's just show, because we're going to solve for delta B in this equation, which is the hypothetical number of ETH I would need to pay in order to get 10,000 hex. Delta B would be equal to, we just do the subtraction here. We multiply them both together. We subtract one side from the other and divide by 866,000. And you can easily calculate delta B on paper or with a calculator, whatever. It's 0.04517. So again, before I even make the transaction, the automated market maker knows that if I want to take out 10,000 hex, if I'm requesting that, it'll automatically do this formula and tell you that in order for delta B to give us the same constant K, I'd have to pay 0.049517 ETH. So basically 0.05 ETH will get me 10,000 hex. That's when this is a liquidity pool, right? So this means essentially that the user has to pay 0.049 ETH to get 10,000 hex. And that's how we price things. And it's easier to understand it using USDC because we're all more familiar with dollars. But how you would convert this to USDC is you would just calculate the price of Ethereum and multiply that by the price of Ethereum to USD. Or, you could go consult the USDC pair directly, because there's actually a hex USDC pair, which would give you a more accurate answer of how much does hex cost in US dollar terms. Right? So you can do it either way. Now, that might have been a little complicated, so let's make it really easy, right? Because, if you can't explain something very simply, you don't really understand it at all. So let me take a stab at trying to make this very, very easy to explain, okay? Let's say you've got coin A and coin B, and you've got 4 of coin A on one side of the liquidity pool, and 4 of coin B on the other side. Well, what's the constant product, right? This is really easy. 4 times 4 is 16, so K equals 16, right? Now, let's say I want to buy 3 of coin A. So I want to deplete coin A's resources by 3, and that would only leave 1 left. Well, what number of coin B has to now exist in order for coin A times coin B to continue to equal 16? Well, 4 times 4 is 16. Now that there's only 1 of coin A left, that means there needs to be 16 of coin B, because 1 times 16 is 16. So does that make sense? I hope it does, because I don't know how I can get much more clear than that, but this is really cool, because this is why, for example, this is why prices change by a square of what was put in or taken out. So because I left only 1/4 of coin A, the supply of coin B multiplied by 4. If I took out half of coin A, the supply of coin B would multiply by 2. So this is how prices are dynamic. And obviously most people don't buy nearly 3/4 of the pool. They're just buying a small fraction, and the coin B supply increases by 1 over whatever you took out. So it's like an inverse proportion. So this is a simplified example in both cases, really, because liquidity is also dynamic. And in automated market makers, anybody can provide liquidity, and people are always putting in liquidity and taking out liquidity. And it's a really dynamic system. So it's dynamic and chaotic and hard to calculate all the time. But the automated market maker on the back end, the code just calculates that for you, that based on the current liquidity conditions, what is K and what should the price be based on K if you want to take out a certain number of coin A or coin B. Now, remember that gamma in the original equation? I'll pull up the original equation soon, but gamma was actually the fee that's paid to liquidity providers. This fee is typically 0.3%. I believe the new Uniswap has different fee options based on what liquidity you're providing, but typically it's about 0.3%. And that is to, again, it was negligible for the example, but fees and the fee structure incentivizes people to actually put up their liquidity. Otherwise, why would people bother locking up their liquidity and risking impermanent loss if they weren't going to get any money out of it, right? So when you do a transaction, a very tiny fraction of that, again, 0.3%, actually gets distributed up among all of the liquidity providers, proportional to how much liquidity they have in the pool. And that, in theory, decentralizes control, so all the liquidity is not put up by a single institution, e.g., Binance or Coinbase, right? These are the middlemen we're trying to get rid of. So how do we make a system without this many middlemen? Well, we allow everybody to pool their liquidity together, and we reward everybody with 0.3% fees, proportional to how much of the liquidity pool they have in, right? And there's a small issue with jump-starting liquidity. It's hard to get people in at first, which is why in the early days of coins, you typically see, founders or central groups of developers putting up most of the liquidity, because over time, liquidity becomes more dispersed and more decentralized. But it's hard to convince people to put up liquidity if, this is the first month that the coin has ever existed, or if people don't even have the coin yet, right? So this is a thing that, starts off semi-centralized and becomes decentralized over time. Now, let's talk about another potential flaw, though, is that sometimes transaction fees aren't enough to offset what's called impermanent loss. And you might have heard me use that word already. Impermanent loss is basically what the condition where, let's say I'm putting up a liquidity pool for Hex USDC, and the price of Hex goes way up, skyrockets, like it already has and like it's doing today. Well, if that were to happen, let's say I put up like 10,000 Hex and, $10,000. Let's just say Hex is $1. And I've got 10,000 Hex in one pool and $10,000 on the other side of that pool. And that's me as a liquidity provider. The price of Hex goes way up. And because of that, there's actually less Hex in the liquidity pool and more US dollars in the liquidity pool. So when I want to take out my liquidity, I have more dollars, but I have far less Hex. And because I have, let's say, 8,000 Hex and $12,000, my impermanent loss is 2,000 Hex. And that 2,000 Hex is now worth much more than $1. So I'm actually at a loss because the price of Hex went up so far against me that basically I'm stuck, left holding these extra dollars, and I don't have as much Hex as I started. Although the price of Hex is now, vastly, vastly higher than the dollars that I have. So this is impermanent loss. That's the concept of it. It's kind of just a BS word for permanent loss, if you ask me. And hence liquidity provider reward token. So this is something in Pulse Chain that we've been talking about might come out one day in the fork of PancakeSwap. Not immediately, but within the first month or two. Liquidity reward tokens are a tertiary or a third token that is typically used to incentivize more people to provide liquidity and make them able to withstand that impermanent loss a little bit more. So imagine if, you got a reward token, let's just call them LP tokens. So let's say you get 10 LP tokens for every $10,000 of liquidity you provide. Well, that would incentivize people to come in and not only gain fees from liquidity, but gain a third token as well, which, as we've seen in the past with things like Quick Token or Cake Token, these LP reward tokens typically tend to increase in price just because, they exist and people buy them. So I do believe that they are kind of silly, but they do tend to work to jumpstart and ignite liquidity. And I think the real idea behind that is that one day, LP reward tokens won't be needed. They're just really needed to jumpstart liquidity to get to a point where, people can make 0.3% transaction fees, and that will be enough for the liquidity providers. So again, remember that this is the equation if you're trying to calculate what something should cost in an automated market maker. It's reserves of coin A times reserves of coin B equals K. And that is the before situation. And again, after you take out some token, let's say you take out coin A and you want to buy that, the after situation is that K does not change because, again, it's constant. But the new reserves of coin A are R of A minus delta A, minus the amount I'm taking out, times R of B plus delta B, which is the amount of token B that I'm putting in order to purchase coin A into my wallet. So this is from the perspective of the liquidity pools, not from my perspective. From my perspective, I'm getting coin A into my wallet, and I'm putting in coin B. I'm paying coin B. Coin B is coming out of my wallet and into the AMM. And remember, gamma is just the coefficient for liquidity, and that can change based on what fees are. So gamma is just the coefficient for fees that are paid to the liquidity providers. So hopefully this made sense. I'll try to make it short and sweet. We won't go on much longer, but thanks for watching. Make sure you like and subscribe if you want more content. And I'll be coming out with a Pulse Chain update video very shortly, probably tomorrow. So I'll see you there.